This is class 29 of my arithmetic course. Today we're going to review for test number 3. Test number 3 is going to cover classes 18 through 24. I would have given this test sooner, but I accidentally covered too many classes before giving the third test. So again, this test is only going to cover classes 18 through 24. Sorry about the confusion, but again, I would have given this test sooner, but I accidentally went too long, so I don't want to give you a test that covers too much material at this point. But it's too hard to go back and retitle YouTube videos, so sorry about the confusion. So again, this is only classes 18 through 24. And classes 18 through 24 covered decimals, percents, and the order of operations agreement. We did an introduction to decimals. We learned operations with decimals, addition, subtraction, multiplication, and division. We introduced percents, and we did a class on applications of percents. How to find the percent of a number. And we also learned order of operations when you have multiple operations, addition, subtraction, and division, multiplication. When you have to write an expression that has multiple operations, you need to know the order of the operations so that you get the same answer every time. It just tells you how to communicate to other mathematicians. And we have applications of percents in the order of operations agreement classes also. So I want you to take a screenshot of this page, because these are some of the formulas that we're going to use. As you can see here, we have finding the percent of a number, and we have your place value chart, which we're definitely going to need, and we have Pemdas, the order of operations agreement acronym that helps us determine the order of operations, parentheses, exponents, multiplication, division, so on and so forth. And we have our percent change equations and our interest formulas. So get a screenshot of that, and today we're going to do a practice test, and I'm going to give you a practice test for homework also. But I want you to be very aware that taking a practice test is not the only thing that you need to do to prepare for a test. You have to go back and make sure that you know how to do every single type of problem. And the first thing that I would look into is the homework, and make sure you can do all the homework without looking at the solutions. Do it and see if you can do it on your own and check your answer. And then if you need more practice, you can go back to the classes, or you can use a textbook if you're using a separate textbook and do practice problems, so on and so forth. But the purpose of this test today and the test for your homework is to give you an idea of what's going to be on the test, or what would be on a typical test that you would see in other places. All right, so let's go ahead and get started. Let's do number 1. It says convert the following decimals to fraction form, then to percent form. So we have 0.6, and we're going to convert that to a percent. So converting to a percent is very easy. You just move the decimal 2 places to the right, 1, 2. But that means we have to add a 0, so it becomes 60%. You can't get any easier than that. You always move the decimal 2 places to change to a percent, and if you want to change back to a decimal, you move it 2 places in the other direction. So you always move it 2 places. And actually, now that I think about it, we probably should change it to a fraction first. Let's change it to a fraction first. So go back to your screenshot there, to your place value chart, and you can see this is the 10th place. It's the number to the right of the decimal. It's called the 10th place. So all that means is that 0.6 is equal to 6 over 10. And there's the fraction. No big deal. That's just the definition of a decimal. That's what this means. It means 6/10. There's no trickery there. It's just the definition of what a decimal is. It's in the 10th place, so it's 6 over 10. But we have to use the fundamental principle of fractions because this fraction is not in lowest terms. So the fundamental principle of fractions tells us we can divide both sides by a number and get the unequivalent fraction, or we can multiply both sides of the fraction by a number and get an equivalent fraction. but you have to multiply or divide by the same number. So if you divide both sides by 2, you get 3 over 5, and that fraction is now in lowest terms. And we should put a comma between those. So see if you can do part B, and when you come back, we'll do it together. All right, we're back. So this one's a little bit more difficult. We have to look at the number farthest to the right and ask what place is that in, what's the place value. Well, that's the third number from the decimal, so look at your screenshot. The third number to the right of the decimal is in the thousandths place. So we write 587 over 1,000. So again, in the last problem I changed to a percent first, but it's actually better to probably change it to a fraction first, so I'm doing that. So now we change to a percent. To change to a percent, again, you just move the decimal 1, 2 places over. So we have 58.7%. And be sure to add your percent sign. It's not a percent unless you add the percent sign. So if you got those answers, good job. And this fraction, by the way, we cannot reduce that. At least I don't think we can. And even if we could, I wouldn't waste your time making you do that because that would take a while. All right, so part C. See if you can do part C, and when you come back, we'll do it together. Now in this problem, I want to demonstrate an important point. All of these zeros here, they're just going to go away because those are ending zeros. Remember, 2,000 over 10,000 just reduces to 2 over 10, which is the same thing as 0.2. So when you have ending zeros to the right of the decimal, you can just get rid of those. And 0.2, that just becomes, well, 2 is in the 10th place, so it just becomes 2 over 10. And if we divide both sides by 2 using the fundamental principle of fractions, we have 1/5. So if you got 1/5, good job. So now to change to a percent, we just take the decimal and move the decimal 2 places over, and that gives us 20%. So if you got those two answers, good job. All right, why don't you try part D, and when you come back, we'll do it together. All right, we're back. This is something different because this is going to be a mixed number because we actually have a whole number. So we're going to have to write the whole number. And then this part we can deal with separately. So you want to go to the, we can just ignore this 0 because it's an ending 0. You could add it if you want to, but you don't need to. So I'm going to consider this to be the number farthest to the right. And we have to figure out what place that's in. So look at your place value chart or go tenths, hundredths, thousandths. You just multiply by 10 each time. 10 thousandths, 100 thousandths, millionths. So the 4 is in the millionths place. The number farthest to the right is in the millionths place. So we're just going to write 204 over 1 million. And 1 million is 6 zeros. Now, you can reduce that, but I'm not going to make you do that. It's not really that important right now, so we'll just leave it in that form. So we changed it to a fraction. Now to change it to a percent, again, you just move the decimal 2 places to the right, and it becomes 3,800.0204. And then we changed it to, oh, I forgot my percent. Don't forget your percent sign. So we have 3,800.0204%. So if you got those answers, good job. All right, number 2, convert the following fractions to decimal form, then to percent form. So in these problems, we started with a decimal and we went to a fraction and a percent. And these problems, we're starting from a fraction and we're going to a decimal and to a percent. And then, of course, we're going to start with a percent in a different problem, and we're going to go to the decimal form and the fraction form. So you need to know how to go back and forth between percents, fractions, and decimals, the three forms of fractions. So 3/10, that's just going backwards. That's a 3 out of 10, so it would just be in the 10th place. Again, you can look at your chart. And by the way, on that chart, I didn't put 10 thousandths or 100 thousandths or millionths. But you can go online and find a chart that has more names if you want. But again, you don't really need to know the names because you can just remember multiply by 10 every time you move to a different place to the right. So we have 0.3, and if we want to change it to a percent, we just take that decimal and move it 2 places to the right, and it becomes 30%. So very easy. Now you can also use the long division algorithm by taking 3 and dividing by 10, adding a 0, and it goes in 3 times. Bring the decimal straight up and you've got 0.3. Using the long division algorithm works every single time. So if you want to just learn one method, you should probably learn the long division algorithm for changing a fraction to a decimal. But I'm not using that method with these particular problems because notice all these problems have powers of 10 in their denominators. Here we have 10, we have 10,000, we have 100 million, and 10 million. So these are all powers of 10 because they're just ones with zeros. So when you have a power of 10, it makes it really easy because that's what a decimal is. It's a fraction in abbreviated form. It's a fraction with a power of 10 in the denominator in abbreviated form. So, for example, 7 over 10,000. See if you can do that one. And when you come back, we'll do it together. All right, we're back. So this is in the this is out of 10,000. So tenths, hundredths, thousandths, 10,000ths. The 7 is in the 10,000th place. Again, there's no mystery here. That's just the definition of a decimal. We're just writing this fraction in a different form. There's nothing complicated going on here. It's just the definition of a decimal. So now we're going to change that to percent. We just move the decimal 2 places to the right, and we have 0.07%. We're going to change it to a percent. All right. So why don't you try? Well, if you got those answers, good job. And why don't you try part C? And when you come back, we'll do it together. All right, we're back. So we have 10 million. So we need 0.10ths. Well, this last digit, that should be in the 10 millionths place, which means that the first digit should be in the 100,000th place, I believe. So we want the 100,000th place, so tenths, hundredths, thousandths, 10,000ths, and 100,000ths, millionths, 10 millions. So there's the decimal form. And we change it to a percent. We just move the decimal 2 places to the right. And we get 0.00843%. So if you got those answers, good job. All right, and see if you can try part D, and when you come back, we'll do it together. All right, we're back. So the last number in the numerator should be in the 100 millionth place, which means that this should be in the 10 millionth place, and then the millionth place, and 100,000th place, and 10,000th place, and 1,000th place. So the 3 should be in the 1,000th place. That's 3 places over from the decimal. Just waiting for my computer to catch up here. Running kind of slow. All right, so 0.10ths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, and 100 millionths. So that's correct. So move the decimal 2 places over and you have 0.304016%. All right, so if you got those answers, good job. So again, we can always use the long division algorithm to change a fraction to a decimal. We could have taken this number up here and divided it by this number using the long division algorithm, but we didn't really need to because, again, we had powers of 10 in the denominators. So that made it to where we could translate it really easily. But in these next problems, it's not quite that simple because we don't have powers of 10. Again, we could just use the long division algorithm. We could just take 1 and divide by 2. That always works. And you should probably just learn that method. But I just want you to be aware that sometimes you can change a fraction to a decimal much quicker. For example, a decimal is a fraction with a power of 10 in its denominator. Again, we don't have a power of 10, we have 2. A power of 10 is 10, 100, 1,000, 10,000, 100,000. 2 is obviously not in that class. But we can use the fundamental principle of fractions and multiply both sides of this fraction by 5, and that creates a fraction with a power of 10 in the denominator. So now we can easily change it to a decimal. That's just 0.5, and the 5 goes there because it's 5/10. And the place value directly to the right of the decimal is the 10th place. It's not the place value, it's just the place name, actually. The place value itself is 5/10. All right, so we change that to a decimal, and then you just move it 2 places to the right to get your percent. So part B is the same type of situation. We don't have a power of 10, we have 5. But you can use the fundamental principle of fractions to get 10 in the denominator. So why don't you try part B, and when you come back, we'll do it together. All right, we're back. So you have 3/5, and if you multiply both sides by 2, you get 6/10, which is 0.6. And change that to a percent, you have 60%. So if you got those 2 answers, good job. All right, part C is going to be a little bit more difficult because we're going to have to multiply by something big to get to a power of 10. We cannot multiply 4 by anything to get to 10. So we have to go to the next power of 10. The next power of 10 after 10 itself is 100. And then the next power after that would be 1,000, and so on and so forth. So we can get to 100. But we're going to have to multiply by something big. We're actually going to have to multiply by 25. And then you get 25 over 25 times 4. I know what that is because I know that 4 quarters is $1, and each quarter is 25 cents. So 4 times 25 is 100. So that would be, that's the last digit, 5, is in the hundredth place when you write it as a decimal. So that would be 0.25. Again, it's easy to write it as a decimal because I have a power of 10 in the denominator. All right, so now we move the decimal 2 places to the right. You got 25%. So why don't you try part D, and when you come back, we'll do it together. All right, we're back. I'm going to go ahead and try to move this down a little bit. All right, part D. We have 6 3/4, and they're going to multiply both sides by 25. And that gives us 6 75 100th. But 75 over 100, that would just be 6.75. And then move the decimal 2 places to the right, and you have 675%. So if you got those two answers, good job. And again, if you want more practice with this stuff, go back to the homework or go to my other videos. You'll have plenty of practice problems in those videos. Again, the purpose of this test is just to give you an idea what's going to be on the test, what's required of you. The purpose is not to give you a complete review of everything that you need to know, even though this is pretty representative. It's gonna show you what's on the test, but it's not going to give you all the practice that you need. All right, on to number 4. So at number 4, we can't multiply 8 by anything to get 10, and we cannot multiply 8 by anything to get 100. So we have to go to the next power of 10, which is 1,000. But if we went to 1,000, we'd have to multiply both sides by 125 to get up to 1,000. And you can see that this is starting to get really difficult, really tedious. So that quick method doesn't work anymore. The quickest method is just to use the long division algorithm. We have to divide the numerator by the denominator. And you always divide the numerator by the denominator. The numerator by the denominator. That's the way it always works. So we can't divide 8 into 5, but we can add a decimal and a 0. Now we can divide 8 into 50. It goes 6 times, and notice I put the 6 above the 0, not above the 5. If you put it above the 0, you're going to get the wrong answer. 8 times 6 is 48. Subtract, you get 2. Bring down a 0. 8 goes into 20. 2 times, 8 times 2 is 16. Subtract, you got 4. Bring down another 0. 8 goes into 40. 5 times, 8 times 5 is 40. Bring down 0. And bring the decimal straight up. And you have 0.625. So there's our decimal. Now move the decimal 2 places to the right, and you have 62.5%. So now when I subtracted, I could have borrowed because I can't subtract, for example, I can't subtract 8 from 0, right? So I needed to borrow from the 5. Remember that stuff, you cross out the 5, and it becomes a 4, and then you give you the 1 to the 10, or 1 to the 0 becomes 10. But when you're doing 50 minus 48, or any of this subtraction, you really don't need to do all that stuff. You can really just do it in your head. These are very easy subtraction problems. All right, so number 5 is going to be a repeating decimal. In fact, there's no number that you can multiply 9 by to get to any power of 10. It's never going to happen. So this is a decimal that just goes on forever and ever and ever. Not that time really has anything to do with it, but it'll just keep going and going and going. So you definitely need to use the long division algorithm for this problem. And remember, when a decimal keeps going forever, you put a bar. You just write whatever the repeating pattern is, and then you write a bar over that. So why don't you try number 5, and when you come back, we'll do it together. All right, we're back. So 7 divided by 9. 9 doesn't go into 7. Add a 0. Goes 7 times. 7 times again. As you can see, it's just going to keep going on and on. You just keep adding sevens. The decimal goes straight up. So we have 0.7 bar. That's the decimal form. So 0.77777777, and then when you move the decimal 2 places, it becomes 77.7 bar percent. Just make sure you don't put the bar over the whole number part. Don't put it over the whole number part. It only goes over the part to the right of the decimal, because it's impossible for a whole number to go on forever unless it's going to become infinity. But to the right of the decimal, it actually would not be infinity, if you can believe that. You'll learn about that in upper mathematics. So if you got those answers, good job. So now we're going to a problem where we have a 2-digit number in the denominator. So we're going to use the long division algorithm. 27 goes in, I believe it goes in 2 times. 2 times 7 is 14. I'm going to use the fast method to multiply. Instead of setting it up over here and doing it that way, I'm going to use the fast method. So I'm going to keep this number here, and I'm just going to multiply 2 times 27. So 2 times 7 is 14, carry the 1. 2 times 2 is 4, plus 1 is 5. Subtract. You can bar if you want to, but I'm just going to do it in my head for time's sake. Bring down a 0, and 27 goes in, I believe, 9 times. 9 times 7 is 63. 9 times 2 is 18, plus 6 is 24. Subtract, I'm just going to do it in my head, you get 17. So now you bring down another 0. 27 goes into 170. Let's see. I'm going to say 6 times. Erase that number there. 6 times 7 is 42. Carry the 4. 6 times 2 is 12, plus 4 is 16. Subtract. Bring down a 0. And then as you can see, it looks like this is just going to start over again, because we already have an 80 here, and now we're starting with an 80 again. So 27 goes into 80 2 times, and it looks like it's just going to keep going 296, 296, so on and so forth. Bring the decimal straight up, and we have 0.296 bar. You move the decimal 2 places to the right, and you get 29.6. We have to start the pattern from 6, so 629. So 629 is the repeating pattern. So again, that's an important point. Notice the repeating pattern starts at 2 here, 296, but then when you move the decimal 2 places over, the repeating pattern doesn't start at 2 anymore, it starts at 6. So be aware of that, because again, the repeating pattern can only be to the right of the decimal. So once you move the decimal 2 places over and it becomes a percent, the 29 doesn't represent a decimal, it represents a whole number. So you have to start the pattern in a different position. We didn't do a lot of those problems, but it's not that complicated, so don't worry about it. Whoops, I got to rectangle that. All right, on to number 7. Why don't you try number 7, and when you come back, we'll do it together. All right, we're back. We can just ignore the 826 for now. That's a whole number. 11 doesn't go into 1, but it doesn't go into 10 either, so we have to add another 0. 11 goes in 9 times. 9 times 11 is 99. Subtract, you get 1. Bring down a 0. After you bring down the 0, the 11 still doesn't go in. So, because it still doesn't go in, we have to write a 0. So you put your 0 up here, then you bring down another 0, and now it goes in to 11 goes into 109 times, and you can see this pattern is just going to repeat. You bring down a 0, it still doesn't go in, so you put another 0. Let me move this over. Another 0, bring down the 0 again, goes in 9 times. As you can see, it's just going to repeat. So bring the decimal straight up, and you see something weird here. There's actually an empty space right here. So we have to fill that empty space with a 0. Alright, so we just add that repeating decimal to the whole number, and we have 826.09 bar. That's the decimal form of our answer. And then if we move the decimal 2 places over, we get the percent form. Make sure you keep your bar on the numbers to the right of the decimal. And that would be 82,000, so we put our comma there. So 82,609.09 bar. So if you got those answers, good job. Alright, number 8 is the last one of these problems where we're converting from fraction form to decimal and percent form. This problem is going to it's going to go on for a while because I'm going to do it quickly because we don't want to run out of time. But whenever you divide by 7, you're going to have some sort of repeating decimal. So we can try this together if you want, but I'm going to go ahead and just do this quickly because I don't want to run out of time here. As you can see, it just keeps going on and on. And we're back down to 30. So as you can see, bring the decimal straight up, and we have a repeat. It's just going to keep repeating in that pattern. So 6 numbers need a bar over them. Change it to percent. And the pattern starts in a different place. So if you got those answers, good job. So again, whenever you divide by 7, it's going to go on for a while. All right, so we're on to number 9. A cat weighs 7 pounds. Its weight increases by 22%. What is its new weight? So this is a problem that applies the order of operations equations. This is a percent change problem. It's when you take a number and you change it by a certain percent. So there are 3 types of problems that we need to go over for percent change. I'm going to go ahead and write those up here. I'm going to bring those equations down so we have them there. So these are the 3 types of equations that you have. And again, you should have these on your screenshot. Again, if you didn't take a screenshot of those equations that I gave you, go ahead and take a screenshot now. These are some of the percent change equations. So this is just the basic problem. You have a 7-pound cat, and you're going to increase its weight by 22%. So that's the first type of problem. It's just the basic percent increase or percent decrease problem. In fact, let me just let me keep that highlighted because that's the one we're using. All right, so all you do is just plug in the numbers, and it's going to be an application of the order of operations. You take the first number, which is 7, and then we're increasing, so we put plus. Notice it says plus or minus. If it's an increase, you plus. If it's a decrease, you minus. So plus 7 times the percent as a decimal. So you have to write it as a decimal. You have to move the decimal 2 places to the right. 1, 2. So this part here is 22% of 7. We haven't done any of these problems yet today, but remember, if you want to find 22% of 7, you just take the percent, you change it to a decimal, which we did, and then you multiply it into the number. So that circled part there represents 22% of 7. So you take the original number, and then you add 22% of that number. That's what it means. That's the definition of increasing something by a certain percent. And I know what you're thinking. You're thinking, I don't like that. That sounds complicated. Well, tough. That's just the definition of increasing something by a certain percent. Just learn it. Learn the formula. This is just the formula that you're going to use. So it's a definition, so don't overthink it. So we have to follow order of operations. This is an application of the order of operations agreement. So I'm going to write that up here. Pemdas. So we do parentheses first. There are no parentheses. Then we do exponents next. So parentheses and exponents next. Then we're going to do multiplication next. We do have multiplication, so we're going to have to multiply 0.22 times 7. And there's 2 numbers to the right of the decimal, so we move the decimal 2 places to the left, starting to the right of the 4. And there's no decimals to the right of the decimal, or there's no numbers to the right of the decimal in the 7. Sorry, I'm just waiting for my computer to catch up here. There's no decimals to the right of this number, so we don't have to worry about that in terms of where to put the decimal. So 2 numbers total, so we count 1, 2 over and put the decimal right there. So we have 7 plus 1.54. So 1.54 is 22% of 7. And it's a percent increase, so we're going to add that to 7. And you don't really need to do that on paper. It's so easy. It's just 7 plus 1 is 8.54. But if you want to do that over here, you'd have to add your decimal and some placeholders. We don't need the placeholders, but they help. And you get 8.54. Then we have to put our units. If you just leave your answer like that, you're going to get a point taken off, so we got to put pounds. The cat now weighs 8.54 pounds after a 22% increase. So we're going to use these formulas throughout this practice test today. Because sometimes, well, I'll get into that later. All right, number 10. Number 10, I think we're going to have a basic perimeter problem. So we're reviewing perimeter. You should know what perimeter is. Perimeter is just the length around something. So if you have a fence around your house or your backyard and you want to know the perimeter of the fence, you just measure the distance around your backyard, around the fence. So you just put like a tape measure on the fence and then go all the way around, depending on how long the tape measure is. Anyway, so we just have to add all these numbers. But notice that these numbers are decimals. So we learned in the operations on decimals class, or the first operation on decimals class, that when you add or subtract decimals, you always have to line up the decimals. So 2.85, I got to line up the decimal again. And then we have 0.973, 0.973. So notice that all these decimals are lined up. They must be lined up or you're guaranteed to get the wrong answer. So now we put our line there. Maybe someday my computer will catch up to what's going on here. There you go. And then we should put some placeholders here. So add up the 0, 0, and 3, and 3, you get 6. Add up those numbers, and you get 24, I believe. 20, carry the 2. You get 36, 7. So at that point, we're pretty much done. We just have to figure out where the decimal goes. But remember, when you're adding and subtracting decimals, the decimal just comes straight down. So it just goes right there. So that would be 7.646. And it's centimeters. So that's the distance around this parallelogram. And again, that's called a parallelogram because these two sides are parallel and these two sides are parallel, which means that each pair of parallel lines will never intersect. They can just go on forever and ever and they'll never touch each other. That's what parallel means. All right, so now on to number 11. The Peregrine Falcon is the fastest animal on the planet. This is true, by the way. It dives at 240 miles per hour. If this bird dives for 0.00573 hours, how far would it travel during this time? So this problem seems pretty difficult, but it's just a basic operation on decimals problem. The reason it seems difficult is because it's not addition or subtraction. If it were addition or subtraction, it would be pretty easy. For example, the problem above, we knew immediately perimeter, you just add the numbers together. But this problem, it doesn't seem very easy. So what does that mean? It means it's going to be a multiplication problem or it's going to be a division problem. So all we have to do is figure out if it's a multiplication problem or a division problem. And we have to figure out, if it is a division problem, we have to figure out what order do we divide the numbers. Do we divide this number by this number, or do we divide the other way around? Do we divide this number by this number? So the easiest way to do this is to just change this number to an easier number to deal with. Let's just change that number to 3. Let's pretend that that's just 3 hours. Now let's try to answer the question and figure out what operation to perform, because now we can figure out things much easier. The reason it's difficult to figure out is because we have a big old decimal there, 0.00573 hours. So now that we have 3 hours instead of 0.00573 hours, let's reread the problem and figure out what's going on here. So we have 200. The Falcon moves 240 miles per hour. What that means is it travels 240 miles for every 1 hour. It takes 1 hour for the Falcon to move 240 miles. All right? Now, it's not moving for 1 hour. If they were asking us how far does it move in 1 hour, we'd already have the answer, 240. It's not asking that. It's asking how far does it move in 3 hours. So if it moves 240 miles in 1 hour, how far does it move in 3 hours? Well, you probably figured out already. Well, you just add 240 3 times. But notice that that's actually multiplication. You're taking 240 and multiplying it by 3. So that gives us the answer. We don't divide those two numbers. We multiply these two numbers. So now that we know that it's multiplication, we just do the multiplication algorithm. So 240 times 0.00573. I lined up the numbers. I didn't line up the decimals. Remember, when you multiply decimals, you don't have to line the decimals up. All right, so we have to multiply 3 times 240, so 3 times 0 is 0, 3 times 4 is 12, carry the 1, 3 times 2 is 6, plus 1 is 7. Again, I'll multiply 3 times 240. So I'm going to erase that number there. Now we put a placeholder, and now we move on to the 7. 7 times 240, so 7 times 0 is 0, 7 times 4 is 28, carry the 2, 7 times 2 is 14, plus 2 is 16. So now we're done multiplying the 7. Now we put 2 placeholder zeros, and now we go on to the 5. 5 times 0 is 0, 5 times 4 is 20, carry the 2, 5 times 2 is 10, plus 2 is 12. And now we're ready because we multiplied all those numbers. And you don't have to multiply these zeros. You can do that, but you're just going to get rows of zeros, which are unnecessary. All right, so again, we put no placeholders in this row, 2 placeholders in this row. Whoops. Let me go back there. So no placeholders in the 720 row, 2 placeholders in the in the 16800 row, and well, let me go back. Not 2 placeholders. I'm waiting for my computer to go here. So we put no placeholders in this row, in the first row. We put 1 placeholder in the second row and 2 placeholders in the third row. I got confused there because I was waiting for my computer to catch up. I don't know why, but my computer's running slow. So you need to know to put how many placeholders to put in each row. So now we add up, and we get the following number. Now we just need to know where to put the decimal. So we count the number of digits in our original numbers, count the number of digits that are to the right of the decimal. Now the 240, the decimal is to the right of the 0, so we don't have any numbers to the right of the decimal in that number, so we don't care about that number. But in the other number, we have 1, 2, 3, 4, 5 digits to the right of the decimal. So that tells us to move the decimal 5 places, and we always start here. So 1, 2, 3, 4, 5. And our answer is 1.3752, and we don't need to write the last 0. All right, so what's our units going to be? Because a lot of students will just stop there, go on to the next problem, and they'll lose a point because they don't write the units. So what are our units going to be? Well, it's really easy to figure out what the units are going to be. Don't get lazy again and just go on to the other problem. It's really easy to figure out. It says, how far would it travel? So what do we have for distance here? What's the unit for distance? The unit is miles. So miles, and that's our final answer. All right. So number 12, I'm going to go ahead and let you do that problem. This is another problem on operations with decimals. You have to figure out if this is addition of decimals, subtraction of decimals, multiplication of decimals, or division of decimals. So why don't you try this problem, and when you come back, we'll do it together. All right, we're back. Billy Bob had $18.07, but he spent $9.23 on popcorn. How much does he have left? So obviously this is a subtraction problem. You're just taking away $9.23. The key is when you're adding and subtracting decimals, you have to line up the decimal. And I'm just waiting for my computer to catch up again. 7 minus 3 is 4. 0 minus 2 we cannot do, so we have to borrow from the 8. It becomes 7. Give the 1 we borrowed from 8 to the 0, it becomes 10. Now we can do 10 minus 2 is 8. 7 minus 9 we cannot do. We have to borrow from the 1, it becomes 0. The 1 we borrowed from 1 goes to the 7, becomes 17. 17 minus 9 is 8. And then we bring the decimal straight down. So we're left with 8.84, and this is dollars. So if you got $8.84, good job. All right, so these problems are kind of distributed randomly. So notice that I'm not really doing everything in order. We had a percent change problem. We had converting fractions and decimals and percents. We had operations on operations with decimals, and now we're going to converting percents to decimals and fractions. So we converted decimals to percents and fractions. We converted fractions to percents and decimals, and now we're doing the third type of problem, which is converting percents to decimals and then fractions. So these are really easy. So the decimal is right for part A. The decimal is right here. Okay. Now it's invisible. We didn't see it there, but that's where it is. Remember, if you don't see the decimal, it's always directly to the right of the number in the ones place. Let me put my percent sign back there if my computer will catch up someday. There we go. So we just move the decimal 2 places to the right and it becomes 0.23. Very easy. So now that we have the decimal form, we can easily write the fraction form because we know the 3 is in the hundredth place. If you look on your place value chart, you always look at the number farthest to the right, and that tells you what the denominator is going to be, 23 over 100. So why don't you try part B, and when you come back, we'll do it together. All right, so we move the decimal 2 places to the right, and we have 0.008701. So that's the decimal form. And the fraction form, we have to look at the number farthest to the right, which is 1. And the 1 is in the tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. It looks like the 1 is in the millionths place. So we write 8,701 over a million. 8,701 over a million. So if you got that number, good job. All right, so why don't you try part C, and when you come back, we'll do it together. All right, we're back. Move the decimal 2 places. And then the 8 is in the thousandths place, so it's 78 over 1,000. And you can reduce that number, but I won't make you do that right now. All right, part D. Go ahead and try that one on your own, and when you come back, we'll do it together. All right, we're back. We're going to move the decimal 2 places to the left, so it becomes 5.2243. Very easy. And now we have the decimal form, so we can easily change it to a fraction. The 5 is just going to be a whole number because it's to the left of the decimal. And then we have to look at the number farthest to the right in the numbers to the right of the decimal, and that's 3. Now we have to ask ourselves, what place is the 3 in? And the 3 is in the tenths, hundredths, thousandths, 10,000ths place, so it's going to be 2,243 over 10,000. So if you got that answer, good job. So we did all 3 types of conversions. We converted from percent to fraction and decimal, decimal to fraction and percent, and fraction to decimal and percent. All right, so number 14. You deposit, so now we're doing an interest problem. You deposit $90 in a savings account that pays 0.8% simple interest annually. If you leave the money in the account for 3 years, how much will you make in interest, and what will be your total account sum? So this is actually a multi-step problem. So before we do anything, you got to look at those formulas that I gave you. And if you look at those formulas, you'll find 2 formulas. You'll find this formula. Whoops, that's not right. I got to wait for my computer to catch up to this thing. Waiting for it to change pens. There we go. So principal plus principal times rate times time, and the other formula is interest. alone, which is P times R times T. So we're going to use both of those formulas. So notice this part is the same for these two formulas. That part tells you the interest that you're going to have to pay, or in this case, the interest that you're actually going to make. So the first part of the problem says if you leave the money in the account for 3 years, how much will you make in interest? The key is it's asking you how much money you're going to make only in interest. So that's going to be the second formula. So I equals P times R times T. And I'm rewriting the formula because I'm showing which tool I'm using to do the problem. And then we just have to plug in the numbers. The principal is how much you're depositing. R is the percent written as a decimal. You must write the percent as a decimal or else you're going to get the wrong answer. So I move the decimal 2 places over. And then T is the amount of time you leave it, and that's 3 years, so times 3. So this is an application of the order of operations agreement. That's where we learned about interest. So Pemdas, I'm going to go ahead and write Pemdas up here. Notice the arrows. The arrows tell us if you have multiplication and division, you just move left to right. It really doesn't matter. When you just have multiplication, you can do any order you want. But let's just keep that tradition. So left to right. I'm going to move these numbers, this stuff over a little bit there. All right, so 0.008 times 90. Actually, I'm going to write it the other way. It's traditional to write the bigger number on top, even though it really doesn't matter. 8 times 0 is 0. 8 times 9 is 72. There's 1, 2, 3 digits to the right of the decimal. The 0, 0, and 8. So we have 1, 2, 3. So 0.720. And we can just leave that. Number off. That 0, we can just leave the 0 off, so it becomes 0.72 times 3. So now all we have to do is multiply 0.72 times 3. And we get 2.16. So you're going to make $2.16 interest if you deposit $90 and keep it in there for 3 years. So that's the amount that you're going to make in interest. But now we have to figure out how much you're going to make in total. So now we're going to use a different tool. Now we're going to use the above equation, the A equals P plus PRT equation. And I'm just waiting for my computer to catch up here. So 90, actually I should rewrite the formula. So P is 90, and we're just going to add it to what we already calculated, which is 2.16, because we already calculated the P times R times T. That was the interest. So now all we're doing is we're just taking the amount of money we had, or the money that we deposited, and we're adding the interest to figure out our total bank account sum. So if you want to do it over here, you can, but it's not really necessary. Just make sure you line up the decimals, because you know you're just going to add $90 plus $2.16 is just $92.16. Make sure to put your dollar sign. If you don't put your dollar sign, you get a point taken off. All right, so again, that's an application of the order of operations agreement. We had addition and multiplication, and PEMDAS told us to do multiplication first, then addition. All right, so let's move on to 15. This is another application of the order of operations agreement, because we're going to be using this formula, and we have, as you can see, multiple operations. We have multiplication, we have division, and we also have exponents in this case. The approximate volume of a sphere is found using the following formula. Find the volume of the sphere below. Alright, so we need to write our formula to show the tool that we're going to use. And I know what you're thinking. You're thinking, why do we have to write the formula? It's already written up there. Well, again, you're showing the tool that you're using. So we are now going to plug in the information that we have, and we know the radius of the sphere. The radius of the sphere is 3 inches. So we're going to plug in 3 for r. That's 3 inches there, so we're going to plug in 3 for r. Let me just wait for my computer to catch up. 3 for r. And now we have multiple operations. We have to follow the order of operations agreement. So again, I'm going to write Pemdas way up here at the top. So Pemdas tells us to do parentheses first. There are no parentheses, so we don't have to worry about that. Then it tells us to do exponents next. We actually do have some exponents. We have 3 to the third power. So we have to do 3 to the third power. That's 3 times 3 times 3, which is 27. All right, then Pemdas tells us when we have multiplication and division, we move left to right. So we're going to do 4 times 3.14 first. And we get 12.56. Then we're going to do 12.56 times 27 next. Put a placeholder. And add those numbers up. So we have 339.12. Divided by 3. So we just have to do one more operation. That's going to be long division. So I'm going to do that over here. So 3 goes into 3 one time. 3 times 1 is 3. Subtract, you get 0. Bring down the 3. 3 goes into 1 time again. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. 0. Bring down the 1. After you bring down the 1, 3 still doesn't go in. So then you put a 0. Then you bring down the 2. 3 goes into 12 4 times. Remainder 0. Decimal goes straight up. So our final answer is going to be approximately 113.04. And this is volume, so whenever you have volume, you need cubic inches. You need to add that 3 after the IN, meaning cube. You're counting cubes. So again, that's just an application of the order of operations agreement. All right, so now we're on to 16. And by the way, you need to memorize all those formulas that we did. Actually, I'm not sure if I'm going to require you to memorize them or not. I'll probably just give them to you on the test. In fact, yeah, I think I'll just give them to you on the test. Anyway. Number 16, 1/5 of a substance is iron. What percent of the substance is iron? and then we'll get to the other part of the problem later. But this is just telling you to change a fraction to a percent. No big deal. So remember, when you change a fraction to a percent, the first thing you want to do is change it to a decimal, and then that will make it easy to change it from to a percent. So the method that always works to change a fraction to a decimal is to take the numerator and divide by the denominator. So 5 goes into 10 2 times, remainder is 0. Bring the decimal straight up, and you've got 0.2. So we changed it to a decimal. Then move the decimal 2 places to the right, and we have 20%. So 20% of the substance is iron. So 20% iron. So that's pretty easy. So it's just converting between fractions or percents or decimals or whatever. Now the second part, what fraction of the substance is not iron? So what fraction is not iron? Well, we know 1/5 of the substance is iron. 5/5 represents all of the substance, because that's everything. 5 out of 5 is everything. So if you subtract 1 out of 5, you're just going to be left with 4 out of 5. Remember, you don't change the fractions when you're subtracting. If the denominators are the same, and when you add or subtract fractions, you don't change the denominator. You just subtract the numerator, not the denominator. So that was pretty easy. 4/5 is not iron. And then it says, write this fraction as a percent. So we need to write 4/5 as a percent. So you can do that in two ways. One way is to, let me see here. Let me move this over. One way that you can do this is the long division algorithm. Divide the numerator by the denominator. And you get 0.8, which becomes 80%. 80% not iron. But the easier way is to go over to this 20% here. We know 20% is iron, and we know 100% is everything. 100% is the entire substance, because percent means per 100. So if you say 100%, that's 100 out of 100. That's everything, just like 5 out of 5 was everything. In fact, 5 out of 5 and 100 out of 100, that's the same thing. It's the same fraction. It's just written in different forms. So 100 out of 100, or 100% is everything. So if you subtract 20%, you just get 80%. That's another way to do it. So again, we're just messing around with fractions, decimals, and percents. So now let's go on to number 17. 8.4% of a 7-pound sample is lithium. How many pounds of this sample are lithium? All right, so this is just a basic, if you look at your formulas that I gave you, the screenshot, this is an application of percents problem. That's these problems here. We have 3 types of these problems. So it's not percent change. Don't confuse the percent change problems with just the basic finding the percent of a number. So these are the basic finding the percent of a number problems, and these are the percent change problems. The percent change problems are more complicated than the simple problems where you're just finding the percent of a number. But there are 3 different types of these problems. This problem is just a basic type. So we have 7 pounds, and we're told that 8.4% of that 7 is lithium. So this is a problem where you're just finding 8.4% of 7. So we already did that in one problem. You just take the number and you multiply it by the percent written as a decimal. And that gives you the answer. Very simple. That's how you find the percent of a number. Take the percent, change it to a decimal, and multiply it into the number. So we're going to go ahead and do that over here. And the decimal goes 1, 2, 3 places. So we have 0.588. And we need pounds. So 0.588 pounds lithium. And we should probably write lithium next to that. So that's just a basic finding the percent of a number problem. So now we go to a slightly different version of this problem. Now here's where you really have to pay attention. So if you want to find the percent of a number, the percent of the number, we'll call it the new number, is equal to the first number times the percent written as a decimal. That's how you do it. I didn't give you equations for this. I did give you formulas for percent change with F, R, and N, but I didn't give you formulas for this basic type of problem. So that's what it is. So in the previous problem, it was just a basic problem. So we had the number, which was 7 in the previous problem, and we just multiplied it by the percent written as a decimal. And that gave us the new number, which was 0.588 or whatever that was. In this problem, it's different. They're giving you the new number. They're saying, let's read the problem. 0.04% of the human body is sulfur. So we know we have the percent. We just have to write it as a decimal. And it says 0.04% of the human body is sulfur. If 0.076 pounds of a man are sulfur, how much does the man weigh? So we're told that 0.04% is 0.076. So the new number, they're giving us the new number. And they're asking for the original number. So that's what's different about this problem. So you're going to be given different numbers and asked to find either N, F, or R in these problems. So the hard part is not figuring out how to do the problem, not figuring out how to do the math. The hard part is just figuring out what type of problem it is and which numbers to plug in. So 0.0004 times what number equals 0.076? Well, multiplication is just saying how many, adding some number up a bunch of times. So this is really asking how many times does 0.0004 go into 0.076? Well, that's division. So we're going to use our long division algorithm. And so it's always division when the number is right next to the letter. Just keep that in mind. So it's always going to be division, and it's going to be the number on this side divided by this number. Most students will just memorize that, to be honest with you, because again, when you're using fractions, it gets pretty difficult conceptually. All right, so 4 goes into 7 one time, and notice I put the 1 above the 7. I didn't put it anywhere else. 4 goes into 36 9 times, and we have remainder 0. So now this is a different situation because our divisor has a decimal that's not right up against this line. So we have to move it 1, 2, 3, 4 places, which means we have to move this decimal 1, 2, 3, 4 places. Then we bring it straight up, and we have to add a 0 there. So in all the problems we did previously, we just brought the decimal straight up, but not in this problem because the divisor had a decimal that needed to be moved a certain number of places to get to this line. All right, so final answer, F equals 190 pounds, and that's actually what I weigh. So I used my weight in that problem. Whoops. Waiting for my computer to catch up. 190 pounds. So you have to know which numbers to plug in. Number 19, if there are 1.8 grams of sugar in an 8-gram piece of candy, what percent of the piece of candy is sugar? So again, we have the new number equals the first number times R. So in this case, they're actually looking for percent. They're looking for R. So 8 is the first number. That's the total mass of the grams is mass. So that's the total mass of the piece of candy. And the new number is 1.8. That represents the percent. And we just have to find what the percent is. So how many times does 8 go into 1.8? That's the division problem. Goes in 2 times. Subtract. Bring down a 0. 2 times again. Subtract. Goes in 5 times. Decimal straight up. And R equals 0.225. But that's not the answer. They're looking for percent. Remember, R is always written as a decimal, so we have to move it 2 places over, and the final answer is 22.5%. So 22.5% of that candy is sugar. So we did all 3 of those variations of the basic finding the percent of a number problems. So I know this seems like a lot of stuff we're covering here, but again, it's really only 3 things. It's decimals, it's percents, and it's the order of operations agreement. It's, let's see, it's 7 classes I think we covered. All right, perform the following operations. So this is just basic Pemdas operations. So I'm going to write Pemdas over here in case you don't have that screenshot in front of you. You should have it in front of you though. And why don't you go ahead and try part A. When you come back, we'll do it together. All right, we're back. So Pemdas tells us to do parentheses first. 5 minus 2 is 3. And then it tells us to do exponents next. So 3 to the second power is 3 times 3, which is 9. And then if we have multiplication, addition, and division, it tells us to do multiplication first. So we get 18. And actually, we can just do 2 operations at the same time. It's not going to change the answer. And then we got 25. So 25 is the answer on that one. So if you got 25, good job. Let's go on to part B, attempt part B, and when you come back, we'll do it together. All right, we're back. Pemdas tells us to do parentheses first. We actually have 2 sets of parentheses. We have brackets, and we have the regular parentheses, the normal parentheses. So we have to do the part in brackets first, and then inside the brackets, we follow order of operations again. So we do parentheses. 10 minus 6 is 4. We can't get rid of the brackets yet because we haven't finished all the operations inside the brackets. All right, so now order of operations tells us to do exponents next. So 5 to the second power, that's 5 times 5 is 25. And a lot of students would make a mistake right now. A lot of students would do 25 minus 20 because they think that's a really easy operation. They want to get it done quickly. But if you do that, you're going to violate the order of operations agreement. It says to do division first. So we're still in the brackets, and we have to do division, 20 divided by 4 first, before we subtract 25 and 20. So now we're still doing the brackets, so 25 minus 5 is 20, and now we can finally get rid of those brackets. Don't rush to the end. We still have to follow order of operations. You multiply first to get 120, and then you add the 1 to get 121. So if you got 121, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, part C. Now, the part C and part D are kind of special problems because this is where we demonstrate the left to right rule. See these arrows up here on the Pemdas? That's what we're talking about right now. We only have addition and subtraction in part C. So when you have addition and subtraction, you don't necessarily do addition first, as PEMDAS says. You do whatever's furthest to the left. So you have to do 16 minus 9 first. If you do 5 plus 2 first, you're going to get the wrong answer. Again, why do you get the wrong answer? Because we're teaching you proper math language, how to read and write mathematics. If I want to communicate to somebody and tell them that I need them to pass me the pencil sharpener or something like that in school, or pass me a piece of paper, I can't say flibbity floo ploo plob flu. I can't say that because that's not proper language. I'm not going to communicate to the person. Well, that's the way it is in math. You can't just write whatever you want to write or say whatever you want to say. You have to communicate in math language. So the math language tells us to move left to right. So we have to do 16 minus 9 is 7. Then we do 7 minus 5 is 2. And then we can add all those up all at the same time to get 5. So why don't you try part D? We have the same thing, division and multiplication, so you have to move left to right. Try that problem, and when you come back, we'll do it together. All right, we're back. We have to do 16 divided by 2 first, and then 8 times 2, and 16 divided by 4. And if you knew your multiplication tables, you would have gotten that right. So if you got 4, good job. Now on to number 21. The area of a trapezoid is found with the following formula, where B1 and B2 are the bases and H is the height. Find the area of the trapezoid below. So this is an application of the order of operations agreement. We're going to write the tool that we're going to use. I know it's already written up there, but you need to write it again because you're showing the person who's reading your paper what tool you're using. You have to show them that tool. So now plug in the bases, which are 5 and 3, and it doesn't matter which order, it doesn't matter which is which. The height is 2. And why don't you try to go ahead and simplify that, and when you come back, we'll do it together. All right, we're back. So PEMDAS tells us to do parentheses first. Then it tells us to multiply, because we have multiplication and division, so we have to move left to right. So multiply, and then we get the final answer, which is 8, and we have to put meters squared because it's area. So if you got 8 square meters, good job. All right, part B, the perimeter of a rectangle is found with the following formula. Use this formula to find the perimeter of the rectangle below. So see if you can do this problem, and when you come back, we'll do it together. All right, we're back. So we're going to write the tool that we're going to use. If you didn't write that tool, you did it incorrectly. You got to show the reader what tool you're using. Then you plug in the numbers to the tool, and by the way, you're probably thinking, well, is 6 the width or is 17 the width? Well, it doesn't really matter. It depends on the way that the rectangle is set on the paper. Usually in this format, 6 would be the width and 17 would be the length, but it really doesn't make a difference in the formula. So we're just going to consider 6 to be the width. All right, so then we follow order of operations. We can do the multiplication first, and we can just do that multiplication together. Now, 2 times 17 is not one of your multiplication facts, but I just did that in my head. And then 12 plus 34 is 46. So we have 46 inches. Now this is perimeter, which means we're not counting square units, we're counting length. So it'd just be inches alone. So if you got 46 inches, good job. All right, so now we're doing another one of these interest problems. So we need to write our interest formula or formulas. And since we already did one of these today, I want you to go ahead and attempt this problem. And when you come back, we'll do it together. All right, we're back. So you borrow $312 from your sister and she charges you 8% simple interest daily. How much money in interest will you owe her after 4 days? So we're going to use the interest formula first. I'm going to write the formula that I'm using, the tool that I'm using. If you didn't write that tool, then you're not showing what you're doing. So you got to write that tool first. The principal is 312. And by the way, the last problem is when you're making money, you're making interest. You deposited the money in the bank. You're giving the bank your money. They're going to pay you money in return for allowing them to use your money. But in this case, you're borrowing money, so you're going to have to pay your sister because she's lending you the money. So the money's flowing in the opposite direction, but it's still all the same calculations. You have to change 8 to a decimal form, 0.08, and then we're going to times that by how many days? 4 days. So now we multiply left to right. And we get 24.96. We're going to multiply by 4. And the amount of interest that you're going to pay your sister is $99.84. So that's the first part of the problem. Now we have to answer what is the total amount of money you will owe her after 4 days. So now we have to use the top formula. So A equals P plus the amount you make in interest. So thankfully we already did that calculation. Going to enter in P, and then the interest is 99.84. We have to do the multiplication first in this formula, then addition. So now we're ready to add, so we can go ahead and do that up here. But again, you must line up the decimal properly, or else you're guaranteed to get the problem wrong. So we just add that number, or those numbers, and bring the decimal straight down. So you're going to owe her $411.84, assuming that you don't pay any of the money back over the 4 days. So if you got $411.84, good job. Alright, so it looks like we have 3 more problems today, and the 3 last problems we're going to do are percent change problems. We already did one of those problems, but we have 3 more problems here. So notice I wrote these 3 formulas. There's going to be 3 types of these percent change problems. So let's figure out what the first one is. A store gives a 20% discount on all items. If a customer buys a hat listed for $8.25, how much will he pay before tax? If the customer has to pay a 10% sales tax, how much will he pay after tax? So let's do the before tax part first. So he's going to pay the store says $8.25 normally, but they're going to give a 20% discount. And the reason for discounts is just to get people into the store. The people think they're saving money, so they want to get the items when they can get them for less. So it's a way to get people into the store and buy the products. So $8.25, we're going to reduce that by 20%. So we did a percent increase in a problem earlier. I think it was the cat problem where he weighed 7 pounds and his weight increased by 22% or something like that. But in this problem, we're going to use a decrease. It's going to be a percent decrease. So we're going to use this formula, it looks like. It's just a basic decrease problem, and we're going to use the minus, not the plus. Again, that symbol here means plus or minus, but we're only going to use the minus in this problem. So n equals the first number, which is $8.25, and minus $8.25 times the percent written as a decimal. So you tell me, what is this percent going to be written as a decimal? Well, if you say 0.2, you're correct. So this is an application of the order of operations. Pemdas tells us to multiply first, so we're going to take 8.25 and multiply by 0.2. And now, this is something different. Notice there are, whoops, computer's running slow again. I'm really sorry about the computer. This computer's only 8 months old and it's already running like a snail. So I don't really understand it. I'm going to have to call Lenovo or Microsoft or somebody. There we go. So notice we have 3 numbers to the right of the decimal. So that means we count three places starting from the right. So we're going to have 1.65. 1, 2, 3. So 20%, or 1.65, 20% of $8.25 is $1.65. So if we're increasing by 20%, we add $1.65 because that's 20% of $8.25 is $1.65. But if we're decreasing by 20%, we subtract. So then we just have to do 8.25 minus 1.65, remembering to line up the decimal because it's subtraction. We can't subtract 6 from 2, so we have to borrow from the 8. That becomes 12. And we have $6.60. So that is the before tax price. That's what the store is going to charge. But the problem is you now have to do a percent increase problem because now we have tax. So now we have to do the same formula. And by the way, I should have written the formula that I was using there. Always write the formula that you're using. So now we're using plus instead of minus. So now the new number is going to be equal to $6.60 plus $6.60 times whatever the tax is, which is 10%. So that's 0.1 written as a decimal. You don't need the 0, but you can write it if you want to. So $6.60 times 0.1, but I'm not writing the extra decimal, so we have 66. Then decimal goes over 2 places, so we have 0.66. So n equals $6.60 plus 0.66. So 66 cents is 10%. And then we're going to add that. And we're kind of running out of room here, so I'm going to go to the right. 6.6 plus 0.66. And you got to line up the decimals correctly. Put your placeholders if you need to. And we have $7.26. So that's what you're actually going to pay at the store. And that's really all you care about, is what you're actually going to pay. That's what makes you decide to buy or not to buy, is the $7.26. All right. So that was a 2-step problem. That was kind of a challenge problem there. So now we use the first formula in that problem. And again, I want to stress, and by the way, if you're thinking this stuff is feeling really much more difficult, well, that's just the nature of math courses. It gets more difficult as you approach the end of the course. And if we're on class 29, we're pretty close to the end. I think there's only going to be about 33, 34 classes, so we're almost done. So just keep going until the end here. You got to make it all the way to the end. So that, yeah, the math is getting more difficult. And I also want you to understand that it's easy to confuse the two types of percent problems. There's the basic finding the percent of a number problems. There's 3 types of those. And then there's the percent change problems. There's 3 types of those. So you got to make sure you know the difference. All right, 24. If a number is decreased by 43% and the result is 2.166, what was the original number? So you can see this is different. This is a percent change problem because a number is decreased by a certain percent. But it's not telling us what the number was. It's telling us what the result is after the decrease. So you can tell this is different. So for this problem, we're going to use the second formula. It's asking for the first number, and they give us the new number is 2.166. And they're asking for the original number. What number was it that was decreased by 43% to get 2.166? So all we have to do, now that we know what formula to use, we just plug in the numbers and calculate, and we're done. So the new number, n, is 2.166. And this is a percent decrease, so we use minus, and 43% as a decimal is 0.43, and that's it. All we have to do is do those calculations, and we're done. So 1 minus 0.43, we have to borrow, because we can't subtract 3 or 4 from 0, so we have to borrow from the 1. 0 becomes 10, borrow from that, it becomes 9, and now we have 10 minus 3 is 7, 9 minus 4 is 5, and bring the decimal down. Again, this is Pemdas. Pemdas tells us to do the parentheses first. So now we're done with the parentheses. Now we have to divide. So we have to use long division for that. Now we have a 2-digit number. So 57 goes into, it doesn't go into 2, it doesn't go into 21, but it does go into 216. 1, 2, 3, let's see, I think 3 times. Notice the 3 is above the 6. You've got to put it in the proper place. 3 times 7 is 21. 3 times 5 is 15, plus 2 is 17. Subtract, and you get 45. Bring down a 6. 57 goes in, I think, yeah, 8 times. Again, you just want to estimate when you're figuring out how many times it goes in. 8 times 7 is 56. 8 times 5 is 40, plus 5 is 45. So you can see we have a remainder of 0. Now we just have to figure out where to put the decimal. Now the divisor has a decimal there. It needs to be moved over all the way to this line. And you can see we moved it 2 places. So we have to move this decimal 2 places. And then it goes straight up. And we have 3.8. So 3.8 is the original number, the first number. That's why I wrote F, first number that was decreased by 43%. So if 3.8 is decreased by 43%, the result is 2.166. So again, I know that seems really confusing, but the only hard thing is figuring out which formula to use. Once you figure out which formula to use, you just plug the numbers in and use Pemdas. All right, so last problem, you can probably tell what's going to happen here. We had the first type of problem, the second type of problem, now we have the third type of problem. And you know, you're probably thinking, I could have organized this much better and put the types of problems in order so we can see what's going on. But you know, keep in mind this is a practice test, so I'm not going to put all the problems in order. I'm just going to kind of scatter them around. So now Gordon had $24 million. His investors gave him an additional $8 million. His funds increased by what percent? So this problem kind of has a twist to it, because usually what in the previous problems, I gave you the original number, which is 24 million, and then I gave you the new number, which in this case would be 32 million, because if you add 8 to 24, you get 32 million. So this is the first number and this is the new number. But in this problem, I didn't give you the new number. I just gave you the increase. So just be aware that's kind of a different flavor there. So I'm trying to make all the problems exactly the same because it's not fair to test you on something that I haven't given you. But on that problem, I just noticed that now. All right, so we're trying to find the actual percent change. So we use, you guessed it, these problems here. But is this a percent increase or is this a percent decrease? Well, his funds increased, so it's going to be the equation to the left. It's going to be the increase. So all we have to do is plug in the numbers. The new number is 32. The old number, or the first number, is 24. And that's it. So Pemdas tells us to do parentheses first. 32 minus 24, you can do in your head, that's 8. Then we have to do 8 divided by 24, so we'll do long division. 24 doesn't go in 8, add a 0. Goes in 3 times. Bring down a 0, goes in 3 times again, and you can see that it's just going to repeat. 3, 3, 3, 3, 3, 3, decimal goes straight up. So R equals 0.3333333, just on and on and on, or 3 bar. But we don't care about the decimal form, we want the percent change. It says his funds increased by what percent? So that would be 33.3 bar percent. So again, the purpose of this test is not to be the only tool that you're going to use to study for the test. This is just showing you what the test is going to be like. You need to go back to your homework and the other videos that I made, or any textbooks that you're using to see these types of problems. And my course is probably going to be a little bit more difficult than most courses or most textbooks that you would use, so keep that in mind. And the calculations that I'm giving you are not going to be they're not going to be written exactly the same, but use all the resources that you have to make sure that you know how to do these problems before you take the test, because if you take the test before you know how to do the problems, then you're just wasting your time. All right, and I'm not going to give another test, so you've got one chance. All right, so this is the homework. Take a screenshot of that. As you can see, the homework is just another practice test. And take a screenshot of this. So it was 25 problems, as you could see. It's always going to be 25 problems in my tests. And be sure to get a screenshot of all the answers. Each problem is going to be worth 4 points for the test. And so that's it for this class. Make sure you do the practice test and make sure you know how to do each and every problem. Again, there are 3 things to study, 3 primary things to study: decimals, percents, and the order of operations agreement. But you got to know how to do every single type of variation of problems that I put in my class and the homework. So that was class 29, and I'll look forward to seeing you in class 30.